Completing the square is a method used to solve quadratics, and we usually use it when a equals 1, but it can't easily be factored by product sum. However, you can complete the square on any quadratic. So we're going to take a look at a quadratic that has an a value that isn't 1 and complete the square on that. So right here we have 3x squared plus 12x minus 5. One of the first things that you could do is to just add 5 to both sides and just leave your linear and quadratic terms on the same side of the equation. And then if your a value isn't 1, you need to factor out your a value so that you're kind of forcing your a value to look like it's 1, right? So we factor out a 3 from the left side. And from here, we're going to have to figure out what will complete this square, right? So sometimes people like to put this plus blank to remind yourself that that's the number that you have to add to be able to complete the square, because we're trying to write a perfect square binomial. And over here, we have to add that same number on the right side of the equation, because what do you add to one side, you add to the other. But you can't just add that blank, right? See how it says 3 times all this? So you have to do 5 plus 3 times whatever it is. And how do you find the number that completes the square? You find half of your b value, and then you square that. So half of our b value is going to be 1/2 times 4, which is 2, and then 2 squared is 4. But caution, you're not always going to get the same number. It's just because half of 4 is 2 and 2 squared happens to be 4. So let's keep going with the process. We're going to put that plus 4 here and both of our blanks. The blanks is also helpful for some people because it helps you not forget to do it to both sides. And then we know that x squared plus 4x plus 4 can be simplified into a perfect square binomial, because that's the whole reason why we decided to put 4 in the blank. So then we can come over here and do 3 times x plus 2 squared equals 5 plus 12. And that's just from simplifying, and x squared plus 4x plus 4 is quantity x plus 2 squared. So let's look at another way that we could go about solving this, or rather completing the square on this quadratic. So again, we're going to move that 5 over. You don't always have to do that, but sometimes that can be helpful. And then we're going to factor out the 3 so that we can force our a value in the parentheses to be 1. And then we're going to decide how to complete the square. It's the same process, but notice in this case, I put the blanks on the same side of the equation. So I'm adding the blank and subtracting the blank. Okay, we know that 1/2 of 4 is 2, and that 2 squared is 4, so that needs to be what's in the blanks. And this can be helpful when your a value isn't 1 and you're trying to complete the square, because it helps you prevent forgetting to multiply by 3, right? Like if you put it in the parentheses, hopefully that'll help you prevent forgetting about the 3. And so then we want to simplify, right? We get the perfect square binomial that gives us our x plus 2 squared. And we have to make sure we keep these brackets because the negative 4 is still being multiplied by 3 as well. And so then you can simplify that and simplify that one more time. And now you've got an equation in pretty much vertex form that you can solve by the square root method. And that's completing the square when you have an a value that isn't 1. So basically the only difference between completing the square when a value is 1 and is not 1 is that if it's not 1, you got to factor out your a value so that you can force what's in parentheses to have an a value of 1. But mathematicians typically use completing the square to solve quadratics when your a value is 1 and you can't easily factor it by product sum.